The sum of the infinite series sin inverse of 1 upon root 2 plus sin inverse root 2 minus 1 upon root 6 plus sin inverse root 3 minus root 2 upon root 12 plus and so on, and its nth term is given sin inverse of root n minus of root n minus 1 upon root over n into n plus 1. Its nth term. Let's simplify this. So sin inverse of, so we can write root n upon root n into root n plus 1 minus root of n minus 1 upon root n plus 1 into root n. So which equals to sin inverse of 1 upon root of n plus 1 minus 1 upon root over n plus 1 into root over n minus 1 upon n, we can write. So which equals to, and here also we can write sin inverse of, just multiply and divide with root n minus 1 upon root of n plus 1 into root of 1 minus 1 upon n, and this is sin inverse of 1 upon root n into, so we can write this as 1 minus 1 upon n plus 1 root over, so root over we can write 1 minus 1 upon n plus 1 minus 1 upon root of n plus 1 into root over 1 minus 1 upon n, and it seems like sin inverse of x into root over 1 minus y square minus y into root over 1 minus x square. So where x is equal to 1 upon root n and y is equal to 1 upon root over n plus 1. So x times of 1 under root of 1 minus y square, that is 1 upon 1 plus root of n plus 1 whole square will come the same. So which is nothing but sin inverse x minus sin inverse y. So we can write this as sin inverse of 1 upon root n minus sin inverse of 1 upon root over n plus 1. And as this sum tends to infinity, so we can start from n is equal to 1, sin inverse of 1 upon root 1, sin inverse of 1 minus sin inverse of 1 upon root 2 plus sin inverse of 1 upon root 2 minus sin inverse of 1 upon root 3, and so on up to sin inverse of 1 upon root n minus sin inverse of 1 upon root of n plus 1. So sin inverse of 1 upon root 2, sin inverse 1 upon root 2 gets cancelled, and these all terms gets cancelled, and the sin inverse of 1 upon root n also will get cancelled with the before term. So finally it's left with only two numbers, sin inverse of 1 minus sin inverse of 1 upon root over n plus 1. So which equals to sin inverse 1 is pi by 2. Pi by 2 minus sin inverse of 1 upon root of n plus 1, which equals to cos inverse of 1 upon root of n plus 1. And since sin inverse x plus cos inverse x is equal to pi by 2, we can use it. Now as n tends to infinity, so cos inverse of 1 upon r plus 1 tends to cos inverse of 1 upon cos inverse of 0, we can write. So cos inverse of 0 is equal to pi by 2. So we can go with an option. So pi by 2 is third option.